Okay, here we go, section 11.3, areas of polygons. Our objective for this lesson here is we're going to find the areas of rhombi and kites. Again, remember review, a rhombus has 4 congruent sides. Four congruent sides. Okay, now 1, 2, 4. And then our kite here has 2 pairs of congruent sides, but they're adjacent. So again, this side and this side are adjacent, along with this side here and this side here are adjacent and congruent. Okay. So, and then once we find that, we're going to find the angle measures in a regular polygon. Okay, we'll talk about what that means when we get there. And then find the areas of a regular polygon. Again, remember regular, bit of vocabulary there. Regular means all congruent sides and angles. Yeah, regular. Okay. All right, first, let's go ahead and let's look at a kite. Okay. A kite, again, sorry, not a kite. This is a rhombus. This is a rhombus. Here's my rhombus. If you remember about a rhombus has 4 congruent sides. All the sides here are congruent, and the diagonals are perpendicular. So if I draw this one diagonal in, and we draw this other diagonal in, okay, they are perpendicular. Okay, so they intersect here at a 90-degree angle. So what we've actually done is we've actually created 2 triangles. If we think of this triangle from here up, we've created 2 isosceles triangles. There's that one. And the base, to find the area of this triangle right here, the area of this triangle, okay, we would again do 1/2 the base of the triangle times the height. Well, the base of the triangle is this length right here. Well, that's just the length of one of the diagonals. We'll call that diagonal 1. So the base is diagonal 1 there. So I take 1/2 diagonal 1, okay, times the height of this triangle. Well, the height of this triangle is just this distance right there. So there's my height right there, my h. And if you notice, that height is half of the second diagonal. Okay, so there's my second diagonal. So if that whole thing's diagonal 2, okay, then my height would be half of diagonal 2. But that only gets me the area of half of this kite. So then I would have to then multiply it by 2. Sorry, it's not a kite, it's a rhombus. I don't know why I keep calling it a kite. Okay, it only gives me the area of half of this rhombus, just this top half of up here. It gives me the area of that half of the rhombus. So for me to get the whole entire area, I would need another one, but these 2 triangles are congruent, the top and the bottom, so I would need 2 of them, hence why I then multiplied by 2 right here. Okay. All right, so then if I multiply that, if I take the 2, let's multiply this 2 times this 1/2 right there, that gives me 1. So then I end up with 1/2 diagonal 1 times diagonal 2. And there is the formula for the area of a rhombus given the diagonals. If I don't know the diagonals, it takes a little more to get to it. Actually, if I don't know the diagonals and I know like a side length instead, like if I know a side length like that instead, if I know like a side length right here in yellow, then we could do it like a parallelogram. It would be just base times height. Okay. But I can do this exact same process with a kite, except I have a few more triangles. But again, I can draw on the diagonals. And again, they're perpendicular. So here we have this perpendicular. And let's just go ahead and let's look at, for example, let's look at this triangle right here, this half. So if I look at that half again, this distance here, well, let's call that my base. That's just the same as the one diagonal. And then my height, this distance here, is half of the other diagonal. Okay. So then again, by the same thing we used for a rhombus here, my kite area would be 1/2 base times height times 2, because I have the two different triangles. I have the triangle over here, and then I have the triangle over here. Okay. So then I would need to take 1/2 base times height times 2. Okay, well, the base would be 1/2. The base of this triangle is diagonal 1. The height is 1/2 times diagonal 2 times 2. Again, multiply those two things, and I have 1/2 diagonal 1 times diagonal 2 for my area. Again, what's nice is these equations are the same for both a rhombus and a kite, so I don't have two different things to memorize. Okay, so here we have the area of a rhombus or a kite with diagonals d1 and d2, so there's my two diagonals, d1, d2, is 1/2 the product of the diagonals. So 1/2 times the product of the diagonals. So let's use an example there. So we want to find the area of each rhombus or kite. So here I have a kite. My diagonal, or directly from top to bottom, so that's the length of the diagonal, is 11. And the distance all the way across here, right there, is 5. So those are the two diagonals. So let's just label this as D1. Let's say that one's D2. So to find the area, I take 1/2 diagonal 1 times diagonal 2. So 1/2 times 5 times 11. So then I end up getting 55 over 2. And my units here are feet, so it's area. So that would be feet squared, which is the same as 27.5 feet squared. So either of those will work, is the area of that kite. Okay. Next one, here we have a rhombus. See, all sides congruent. That one, and that one, and that one, and that one. Okay, but again, I know the diagonals because I know this full distance from top to bottom. I know that diagonal there is 10. Oh, 10. And this across this way, this diagonal here, I know that diagonal is 24. So I can write my formula that area equals, again, I encourage you to write the formula down each time. Diagonal sub 1 times diagonal sub 2. So it'd be 1/2 times 24 times 10. I'm going to multiply the 1/2 times the 24 because I can do that in my head. 12 times 10, which gives me 120 square millimeters. The area for that guy. Okay. All right. Next. Okay. We have to talk about a little vocabulary. Okay. First of all, again, a regular polygon. All the sides are congruent. Okay. And all the angles are congruent. Okay. The center of a regular polygon is if I had a circle. Let's see. No. I'm not sure I can get this circle to work out right. If I had, we'll just freehand it. If I had a circle that went through all, hey, not bad. Oh, that last bit was kind of a little crazy. Let's fix it. Okay, if I had a circle, okay, that was circumscribed about this polygon, the center of that circle, right here, this center, the center of the circle right here, would be what we call the center of that regular polygon, okay? And then the distance, okay, from one of the vertices to that center, oh, didn't mean to do that, sorry. The distance from one of the vertices to the center is what we then call the radius. So there's our radius. Okay. So here, our center of a regular polygon, again, is that point smack dab in the center. So here's our center. Let's call it point P. So our center of a regular polygon would be point P. It's really the center of the circumscribed circle. Okay. And the radius of a regular polygon is again that radius of the circumscribed circle. All right, so now, all right, so now to talk about, so there we have our radius. So let's go ahead and let's label that as R. So here's my radius right here, my R, okay? But if I draw 2 radii in, and if I drew in all of my radii, let's draw them all in. If you notice, I can always divide this into a whole bunch of triangles, okay? So if I draw in all the radii, I can draw all these different triangles in. And if we zoom in, and if we zoom in on just, let's say just this one triangle right here, let's just zoom in on this one triangle right here. The length of the one side is R, okay? The length of this side, okay, is again the side length of my whatever, my polygon, whatever it is, okay? Again, here I have a hexagon. It could be 7 sides, could be 8 sides, doesn't matter, okay? But then the height, so if I think of this side as the base, this side is my base, right there, there's my base. The height there, okay, would be actually this distance right here. That perpendicular distance there is my height. That's what we call the apothem of a regular polygon. The apothem is the distance from the center. So that apothem is the distance from the center of that polygon to one of the sides. Again, it's going to be the same to all of the sides. Again, to a regular polygon. Okay. Oh. Okay. And then if you see here, then we have these angles. Hey, we have all of these, stop doing that. We have all of these angles inside of here. So the angle, each one of these angles here, this angle here, let's call it theta, is going to be the same for every single one of these triangles. I'm talking about this triangle or this triangle or this triangle. Okay, that angle theta, if it's regular, is going to be the same. So that central angle is again that angle formed by 2 radii. Okay, so for us to find the area of these, really we're going to kind of break it down into, can I find the area of one of these triangles? Okay, just one of these triangles. Okay, and so here, take one of these triangles, find the area of one of those triangles, and then multiply times the number of triangles that we have. So we would take the area of one triangle and multiply it times the number of triangles. Okay, but this is going to take a little bit of some of our trig and stuff like that to figure out the area of each of those triangles. But the number of triangles would just be the number of sides. If it has 8 sides, it would make 8 triangles. This has 6 sides, so it makes 6 triangles, which kind of makes sense. Okay. All right, so to find the area, okay, of a, finding central angle. Okay, we didn't talk about that. To find the central angle, if you think about it, the angle all the way around, the angle all the way around the circle. If I started here, went all the way around, it'd be 360. But I'm not going all the way around. I'm dividing that 360 up into a certain number of pieces. So if n is the number of sides, okay, then the angle of one of these triangles would be that 360 divided by the number of sides. Okay, and so we end up using that to help us find the area here of these regular polygons. Okay. All right, so the area. So now here's how we find the area of a regular n-gon, meaning n here, again, n-gon. N is the number of sides. N is the number of sides. So this works for whether I have an 8-sided figure or 12-sided figure, but again, important word here, it's regular, so all the sides are congruent. It's regular. With a side length, S. Okay, so here we have our side length S, so the length of one side here, if you see over here, the length of one side is the S, that's the side length. Okay, So to find the area, I would need half. Again, this just comes from that idea of, and if we, these equations can kind of seem a little confusing, but if we break it down into the triangles, this triangle here. So I would need to take 1/2 to find the area of that triangle. It'd be 1/2 times the base. Well, the base is going to be half of the side length times the height, which is the apothem. Okay, but then I'm going to need to multiply that times the number of triangles, times n, the number of triangles. Okay, does that make sense? Kind of. Times the number of triangles, which the number of triangles, but this s, that's just taking into consideration the distance all the way around. So that's where this one comes from, that p. Let's erase that, it's kind of confusing. Okay, so this one I would need to take 1/2, the apothem, the height there, that distance, again, that's that apothem, 1/2 of the apothem times the perimeter, because the perimeter comes from, the perimeter again comes from, if I had n times s there is the perimeter. Okay. Oh, no, I don't need another half. Sorry, I had that extra half in there. That doesn't go in there. Erase it, because the s is the entire base. The height is the apothem. So if you think about this triangle, again, area is 1/2 base times height. And if I'm just looking at just this triangle right here, the base of that is s, the height is a. So here's the equation for that triangle, 1/2 SA. Okay. Then n is the number of sides. That's the number of triangles I need. So I could do 1/2 a times n times s. So that's this equation right here, this guy right here. 1/2 a times n times s. They just rearrange the order a little bit. No big deal. Okay, just multiply the apothem times the number of sides times the side length. Okay, but if I take the number of sides, okay, if I take the number of sides here, so let's say there's 8 sides, times the side length, I don't know, let's say the side length was 10. Okay, that would give me the perimeter. So if I put this n and this s together, okay, that gives me the perimeter. So then that's where this equation comes from. 1/2 a times the perimeter. Okay, so depending on what information you have, kind of determines which of these two equations you want to use. But sometimes it gets a little tricky finding that apothem. Okay, so let's go ahead and let's try one. So here we have a mirror in the shape of a regular nonagon. Nonagons, how many sides? If you're not sure, they have a picture. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So I have a regular 9-sided figure. So this thing's got 9 sides. So that's, again, my n. My n is the number of sides. It's got 9 sides. Okay, and it's got 6 inches on each side. So that's the length of each side. So that's my s. My s is 6 inches. So now if I draw in my center, so I'm going to go ahead and I'm going to draw a point for my center. And I'm going to draw 2 radii in. So really, what I need to find out now is the apothem. I need to find this distance right there. That would be my a. Okay, so that would be my a. Okay, so to find that, we need to use some of our triangle stuff. Okay, because I know the length of this triangle. I know this is 6, but then I also know, let's erase that, I also know half of it is 3. I know this little piece is 3. And now, that's all I know. That's all I know is that little piece is 3. So now I need to find everything else. So to find that A, I'm going to have to know some angles, and this is where that central angle comes in. So all the way around is 360. So this has got 9 sides. So I would need to find for my central angle. So first thing I need to find that central angle. So I would need to take the 360 and divide it by 9, number of sides. That gives me 40. But that's this whole angle in here. That's all the way from here all the way around. That's that whole angle. I only want half of it. So that little angle is going to be 20. So this little angle right in there is going to be half of that, which is going to be 20. So I'm going to draw a little sketch of this triangle that I have here. So there's a triangle. Wait, let's orient it the same way. let's go ahead and let's orient it the same way. So we're up like that and like that, right angle. This is 3. This little angle here is 20. And I'm trying to find this side A. So this is why we always do the trig before this section, because I'm going to have to use some trig here. I know this angle, 20 degrees. I know the opposite side. Okay, I'm trying to find the adjacent, so that I'd have to use tangent. The tangent of 20 degrees equals A over 3. So multiply both sides by the 3. So then A would be approximately, we take 3 times the tangent of 20, which gives me A is approximately 6.71. Okay, so that is the height of that apothem. We're not done yet. We just found the apothem. And again, that's in inches. Okay, so now that we know the apothem, now I can go ahead and use one of my formulas. So let's go ahead and let's go back. So I can take 1/2 A times P, or I really like this one instead. This 1/2 ANS. Okay, so I need to take, to find my area, I need to go 1/2 A times N times S. So we're going to go 1/2 my A, which is 6.71, times N, number of sides, which is 9, times S, which is 6. So now we just go ahead and type that all in, 1/2 times 6.71 times 9 times 6, and we get 181, my area, 181.17 square inches. All right. Oh, okay. So there is the end of the lesson. Again, the apothem's the hardest part to find. Okay, but don't skimp. Make sure you show all the work on doing that and break that triangle down. Okay. All right. Any questions? Okay. Good luck. You stop.